Hi there. Good Monday? We're Monday. It's Monday. Happy Monday, everybody out there in STEMfinity land. I'm Josh, and I'm over here today with, there you go, with Pete. He's over here. Pete. He's going to be pushing all the fun buttons and doing all the fun things that Pete's like to do. Fun over this. You hear a weird sound effect? It's because it's a Pete. I think Pete's over here focusing a camera or something. Pete's everywhere. So we're here today with the fun folks at STEMfinity.com, as seen in the small logo in the corner. STEMfinity. Yay. To talk about some of the fun... Oh, there it is. Look at that. See, there's all Pete. To talk about one of the cool products we have that just came out, the STEMfinity just started carrying, our really cool Crazy Circuits bit board, which is a fun Lego-compatible breakout board for the microbit and the wonderful parts and accessories we have to go with that. So we're going to talk about that today. If you have questions or comments, please throw those up into the chat. I assume most people are watching via Facebook. Pete is actually monitoring those and will let me know if there's any interesting comments that are coming through on that so that we can answer them. So please ask questions. These kits are available on STEMfinity.com. We have a couple different versions of them, but enough chit-chatting. Oh, one last thing, too. And the projects in the table that we're going to be showing off today, some fun projects and activities and lessons, they're all available as project write-ups. All these things are things we've written up. Actually, Pete mostly has written all these up as project guides. So if you're like, that looks cool, I want to do it myself, we have a guide on how to do that. And if you don't want to use a bitboard, you want to use a microbit and something else, a lot of it is you could probably replicate other ways, but our way is a really cool way of doing it. So we're going to stop looking at my face right here and go to the overhead camera. Yay! Oh, look, there's still me in the corner. How did that happen? Go figure. So we're going to actually start here from the beginning. So, microbit. What is the microbit? If you're not familiar with the microbit is a fun little programming platform from the Microbit Foundation out of the United Kingdom, the UK as the fun people call it. It was designed with the British Broadcasting Corporation, the BBC, and a bunch of industry computer people in the UK as a learning tool for classroom kids, as a low-cost, fun, all-around, easy-to-use microcontroller, as opposed to, say, using an Arduino or a Raspberry Pi or something kind of like that, as a very straightforward and very kid-friendly, especially very teacher-friendly, parent-friendly microcontroller. It's all in one with a lot of built-in fun features. Little display screen, built-in buttons, alligator clip-on to here, blah, blah, blah. Built-in Bluetooth. It's got a bunch of fun features in it. Actually, this is the old version, version 1.5. There's a new version that's out that has even a couple more features on it, too. But a low-cost thing. Typically, these cost in that $16 to $20 range, depending on what configuration you get them in. So pretty inexpensive for a nice, easy system. But one of the big key selling points is the drag-and-drop visual interface, which is through Microsoft. It has a nice website where you can just drag and drop code around and makes this puppy work really, really, really well. I've had a huge focus on educational content for this. Now, the only downside of the microbit is often you're kind of limited to what you can do here. A couple button presses, a few little outputs, which doesn't really fully use the full awesomeness that the microbit has. It has a lot of really high-end features built into it that just aren't easily accessible from the base configuration. So a lot of people, like us, have put together really nice little breakout boards that let you use all the fun aspects, if I can do this properly. There we go. That you can use all the fun features on there. You actually use all 20 pins it has, as opposed to just the 0, 1, 2 here. You can use 20 different inputs/outputs and a variety of other components and sensors and whatnot. So we put together this wonderful little thing here called our bitboard, and this is one of our Lego compatible components. These parts just pop onto Lego. Yay, Lego. Or any Lego compatible thing. Like if you're a Megablocks? I think Megablocks. There you go. Megablocks person. You can use it with Megablocks. I don't know why you would be, but you could. So we put some nice features on here. We have some pin headers for plugging in bigger and better components. We have power inputs for it. We have a built-in relay, which lets you control dumb things like a motor or a buzzer or a fan. Just DC devices, just easy controlling of them on and off, as well as all the wonderful outputs so you can use Lego as a circuit board environment. And so we're going to show you how we've done that in a few different ways, and then show you some of the wonderful coding we have and how that all works together. Now you're probably wondering, Josh, that looks pretty cool, but I am just a classroom teacher with a budget of lint in my pocket and some paper clips and maybe a donated pencil or two. I feel your pain because I was that teacher too. But luckily, these kits are pretty inexpensive. We have a couple different versions of it, ranging from a small little standalone kit to some full-on kits with a bunch of different parts and components for a wonderful Crazy Circuits Lego-y environment. This is an example of one of those bigger kits. Components galore, can come with or without a microbit. Got some fun stuff in here. We have a full classroom set that has curriculum. Andy, our poor curriculum writer, is chained to a desk in another room, just hammering away at curriculum left and right. Poor guy, just never gets out much. But so you can actually have nice classroom curriculum, so it's very just not cookie cutter, turnkey. There's the right word, turnkey. You can pop up with the kit, you can use these things, make some of the projects, do the curriculum we have without having any background knowledge, any background experience in the microbit environment. Because we know a lot of teachers, it's new for them and they want to get into things, but it's learning for them as well. So this is one of the kits we have, and we have these nice cards in there. But we have a couple different versions, including big classroom sets. These probably aren't appropriate for distance learning because of the price point. However, once you're back in the classroom, or if you're running a summer camp where the kids are coming in and doing things, which may or may not be happening this year for you, these work really, really well because of how user-friendly they are for kids. And I say user-friendly, I say microbits really targeted to what, as low as 3rd grade, would you say, Pete?
Yeah.
Yeah, we see, yeah, 3rd and 4th grade, just because of the easy drag and drop interface. I always say 4th grade on up for everything, just because as a general catch-all, more the dexterity of kids using small components. But that's just us. If you have really advanced 3rd graders, go for it. You know your students best. And so let's go over a couple of these fun projects. So Pete, let's do a very simple project first and foremost. I have to grab power from over here. There we go. There's my big old power cord. Oh, do we have that?
We just switch that cable.
Should switch it. There we go. We'll go this way there. There we go. So our bitboard is here. We've used our wonderful nylon conductive tape, our maker tape, as it's called. Pete, you have a thing to throw up about maker tape?
Oh, maker tape? Is that
Oh, usually it's something he throws up all the time. There you go, hashtag maker tape. Maker tape is our nylon conductive tape we put in all of our kits, from paper circuits to Lego stuff. It's nylon, not copper foil, because copper foil is horrible. This is nice and strong and sturdy. Oh no, copper foil! Someone's burning you on screen. What's that?
Oh, it's garbage.
Pete worked so long on that. Literally dozens of minutes.
No copper tape.
Anyway, no copper tape. But so we can make a nice circuit board for our microbit project, which is very true to life because we're using real parts, LEDs, we're using a microbit, we're using real push buttons, but the kids are making a real circuit board out of it, and parts are connecting together. Now you can do the same thing with just our regular components without any wonderful, oh no, I'm out of power, it's been sitting here all weekend. It's from last week's project. But you can do the same thing with regular, just standard basic circuitry stuff, but we like doing it here. Now this is a very simple project. It's a push a button to make something LED turn on. Very simple. Or you can do fun animations. What is this craziness? Animate. Now this is very simple to do with the Microsoft drag and drop interface. It is real programming. You can switch back and forth between the drag and drop interface. If you're familiar with Scratch, it's very similar to Scratch, but I would say a little better, maybe. Yeah, maybe a little better.
And Josh, you can use Python or JavaScript if you want to type words.
Python and JavaScript. You can actually do like the full-on, like hardcore coding that some people really want to see for kids. You can do that as well and have the exact same kind of outcome. We just like the drag and drop because it adds a lot of exploration to what the students can do. They've mastered how to make an LED turn on and off. What else can I do? Well, play around. There's no harm, no foul. There's no way to mess things up. And you're not going to hurt anybody or anything. Now, Pete, maybe we could show an example of what that code looks like. Or just any old drag and drop code.
Sure.
Pete's going to get to that in a bit. So there's this kind of thing you can do. Very simple, very straightforward, very light up LED aspect. And in fact, you can take something simple like this, which is just 3 LEDs, or you can go what I like to call a little bit crazy. If I can grab things. There we go. I'm going to switch it around again so I don't have my stuff flying all over. Oops, there we go. We can go a little more crazy. Here's a whole bunch of LEDs.
Whoa. Try that last button, see what happens. Oh, yeah.
What is this insanity? This is just more of the same, what we were doing before, except much larger. And this would be like a big circuit board. And really, if you think about it, a circuit board you'd buy from a factory like we have here that we literally made up for our Crazy Circuits bit board, an actual circuit board, is no different than this. It's conductive tracings, copper versus our nylon conductive tape. We've got real components, LEDs, just like on here. And we've got buttons and other things. I mean, it is the same thing, except instead of being on fiberglass, we're on a piece of ABS plastic.
Hey, look, code.
Oh, there you go. There's an example of code. There would be, was that for the little, the distance?
This one is actually our surprise ghost. Yeah.
Oh.
Surprise ghost.
Our surprise ghost. So this is a fairly quote-unquote complicated thing because it's using a distance sensor, but it's still very drag and drop, very easy to change, very easy to see. Something like making an LED simply blink is much, 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 much easier.
Yeah.
So we're going to put this little dude to the side and go to a little bit more here. Because one of the cool things with the microbit is that it does have the power to do bigger and better things than just LEDs blinking. And I know we spent a lot of time looking at a lot of microbit projects. Microbit's been around for about 5 years now as a platform. And there's a lot of great content. However, the biggest issue for us is that a lot of it is built for new users, beginners, people who have never done programming before and want just a couple fun projects to do with 4th, 5th, or 6th graders. It's very, very, very simple stuff. However, what about once you get past that? If you're an educator, you have moved past it, or you're an 8th grade teacher, kids did this in 6th grade and 7th grade, now they're in 8th grade, you're like, well, LEDs blinking is old hat. We don't want to do this anymore. The microbit does have a lot of nice built-in features in itself, and can accept a lot of outside stuff as well if you have a way to access it, like using our bitboard here. So, for instance, here's something Pete was making up today, actually, as a little guide. This is using a simple distance sensor. I'm going to plug this guy in here to show you what this is. This is just a simple ultrasonic distance sensor. These are very inexpensive and found literally all over the internet for $5 or less. We include these in our classroom kits. And so, it might be hard to see, but it's showing a number on the little display here.
It'll show X if it's more than 9 centimeters away.
This is our test activity. If somebody has a problem with the distance sensor, we have them make this activity to make sure it's working or not. If the problem is them or the distance sensor, this is how we troubleshoot things. But this is very simple. Distance from this little guy is displayed on here in the form of centimeters. X is more than 10. And in this case, there. Now, this is very simple and straightforward. And we're able to do that by plugging it into the breakout we have here. Very simple to wire up. If you're a 6th, 7th, 8th grade teacher, running 4 little wires here to 4 little wires there. It's simple. It's not difficult to do. It's not hard to get right. Connecting 4 guys here to 4 guys there, not a problem. The nice part is, you can then expand on this further. Like the code Pete showed there was distance equals motion. We had a little servo in that project, in that code, where when somebody got within a certain distance, servo shot out like a little ghost on like a little popsicle stick, a ghost on a popsicle stick, a little cutout ghost, and popped out from behind a door. Very super simple cause and effect sensor output in the case of a small servo, also plugged into here. Very simple, very easy, very student-led, because then you can also talk about, okay, well, let's change parameters, let's change what happens. Now, the new microbits have a built-in piezo speaker on them, so you can actually then do motion and sound with it, and you could do a lighting effect. There's a lot of great things you can do with the inputs and outputs, and that's why we always like to see with kids. Inputs and outputs. Something happens, there's a reaction, which is what robotics is. Something happens, there's a programmed reaction. And that is really awesome to have kids realize they can do that and then take it further and do silly things. Because when they do silly things, they're motivated in trying. Because that's what most of the things all the adults I know do. Very silly things. So we're going to put that to the side. For instance, a silly thing you might want to do is this. This is our... Oh, is he even on, Pete?
I believe so. Press the button.
There he is.
There you go.
So this is a project Pete made for when you get when you're on your iPad, it says, "Are you a robot?" You can put this down, press a button, and the robot moves it. Again, silly project, but button press equals servo move. A little Lego-based servo we have in our kits in a very simple environment.
What's that stuff on the yellow Lego?
Oh, that's more of our maker tape, our nylon conductive tape, because it's conductive tape, and it works well with a touchpad. That's right. You want to get that glove of yours to work on an iPhone or something in the dead of winter? Can throw some conductive thread on there, or just make your life easy, throw on some conductive tape, because it's easy. So little stuff like that. Now you can also take things further, say with a distance sensor, and you can make, thank you, Pete. You can take a distance sensor, you can take a couple of servos like this, and a whole just random bunch of Legos we had. This is nothing fancy, it's literally just some random Legos. And we can make a wall-avoiding robot, which is a very classic kind of robot for people to make. And this guy just goes forward until he runs into something. When the distance is below a certain amount, it backs up and turns. That's all it is. A very, very simple little robot with 2 little continuous rotation servos and a distance sensor and a microbit. We also have a little battery pack underneath too. The battery pack comes with all of our kits because they're handy. But this is one of those simple robotics things that you could have students make up fairly easily. And we like Lego because Lego takes the hard part out of doing mechanics. There's nothing more frustrating than having really good code and not being able to do anything because you suck at doing mechanical stuff. And I have been there before myself. Legos are a very easy environment. Kids know how to make things out of Legos. It's not difficult to do. And it's just distance and 2 little servos. And Pete has some great code for that too that he has written. So if you want to follow our code or have some of your more advanced students come up with their own idea, you can, or modify our stuff to do things. Because this is very simple. You could add more onto it. You could do actually a lot with this guy. If you wanted to, we just took a simple route because we want a simple demo for wonderful presentations like this. Now, in addition, before just like doing that kind of stuff, like we can also do some other bigger and more interesting parts as well for those more advanced users. Now, distance sensors, 7-segment displays, even little thumbsticks and servos come in some of our kits, especially our bigger kits in our classroom sets, because we want the kids to be able to explore and try some bigger projects. Now, you can also bring in some other parts as well. For instance, this little guy here. Oh, I should probably plug this in first, shouldn't I? There we go. There's my battery pack, which comes in all of our kits. Little quick, easy connector down here. Fairly impossible to run backwards. We made a clock. That's right. We made a wonderful clock. It is 3:18 in the afternoon here in beautiful Milwaukee, Wisconsin. Cold and frigid. But we turned this into a very expensive clock by using like a $3 real-time clock module we got off Amazon. So again, something that's fairly standard for people to do with Arduinos and other microcontrollers, but you rarely see people do with a microbit, even though there's information and resources out there. Well, if the kids want to make a clock, understand, well, you have to have the right kind of timer on a clock to make sure your time is accurate. That's an interesting point. Depending on how you do things with the microcontroller, your time can be off just a bit. That adds up a lot over time. And the same thing with the microbit. It doesn't have a real-time clock module on it to keep real time. It's pretty close, but not exact. So you can use a simple little guy like that to add real time to things. So even when without power, I unplug things, little battery in there keeps things ticking, the little backup battery. Another good example of using a 7-segment display. Now again, we can use a 7-segment display with a distance sensor. We could use that with a thumbstick, use that with a potentiometer to display different outputs through the microbit. A little more quote-unquote high-tech, maybe get some more oohs and ahs from the, say, 8th graders through high school crowd, but also very, very simple to utilize, very simple to do simple messages on. Write your name. I can write a Josh on mine very poorly. It comes out okay. Josh is easy to do on there. So a lot of those letters, not so much. Some of those letters are just are not easy on the 7-segment display. Sorry. But other ones are. Letter T's, not so much.
No.
J's, great. O's, even better. But easy to put together because we make it very simple to hook things together on here and then connect additional parts if you want to with the tape. So we're just trying to get keeping things friendly, easy to use for the kids and adults, and also have a very reliable outcome for them. Building confidence, building use, honestly, building that wonderful child enthusiasm to try to build their own darn stuff.
And Josh, a clock on its own is kind of boring.
It is.
But you can set custom alarms, and you can set an alarm so like it goes off at noon on your birthday, or like the last day of school, it plays a little chime or something, or it moves a servo.
Actually, Pete makes a very good point. I
up.
forget the fact that you can then cause and affect things too. Duh.
Yeah.
It does keep date and time as well, so you can actually say on February 17th at 2:15 in the afternoon, a horrible buzzer goes off for 1 minute. And that's a legitimate thing to do because sometimes you want to have an alarm at a random time or a servo turns. And you think of those, I think the like Rube Goldman, like Pee Wee Herman-esque, like crazy cause and effect things that go on. You could make your alarm clock that hits a servo that drops a bucket of water on you. You could do that with a microbit if you wanted to, because that's a silly project I'm sure somebody will end up doing one day. But it's not tough to do with like $3 real-time clock module we got randomly off Amazon to try out, because why not? We wanted to try out some bigger and better things. But again, it shows you the expandability you can do with microbit if you have the right platform to work off of, especially when you're working with the fun people at STEMfinity.com. they're nice people to work with. Now again, we kind of took things a bit further because we were trying to see how far we could push the microbit, because we know we get questions from teachers, especially middle school and high school teachers, who want to know, like, well, how much further can I take things? My kids are bored, they've gone through all the activities, what next? So we took a little tiny, this is an OLED display. This is a fairly inexpensive, I think these are like $5 each on Amazon. We don't even carry them, we just thought it'd be fun to do. And hooked it up to a microbit with one of our little potentiometers here. And Pete made this little thing here. It might be hard to see on camera, but it says, "How awesome are you?" And with a number that goes up as you turn the potentiometer. So how awesome can I be, Pete?
Woo, you could probably be 200, no, 100%.
Oh, I guess it's 100%. But this is a good example of using a potentiometer with an output. Now, I can use potentiometer to control LEDs, for instance, multiple LEDs. I can use potentiometer to change where a servo goes. There's so many things you can do with potentiometer for a little easy input and an output. Pardon me. Could you have fun sound effects? Pete often does little synthesizers with multiple. They're horrible on camera. They're hard to pick up with the microphones. But using multiple potentiometers to change pitch, note, sound, and just effects. And you can make a fun little synthesizer to annoy everybody around you with using some potentiometers. And again, that's a project that's not tough to make for a 6th or 7th grader, that has a very interesting outcome that they themselves have made and can tell you how it works. And it's entirely student-led. Yeah, we'll give them example code on how to do that. However, it's the kind of example code where they can easily replicate it if they want to change things on their own, modify it, or start over again from scratch. So this is a fun thing to do with potentiometers, which you do include in all of our classroom sets because those are fun. Now,
Josh, that looks complicated to hook that up, but
it's not.
We've got these kind of lovely diagrams that explain it. There's instructions and directions.
And that's why we have fun stuff in our curriculum as well that we've written that poor Andy's slaving away at. And we're actually working on videos. The next thing we're doing little video demonstrations of all the different projects in our curriculum. So if you're a teacher who is new to this, you can see how what the outcome is. We can help you walk through some things with you. Really making sure that it's easy if you've never done this before, that you can get things going. And this kind of thing right here is probably the most quote-unquote complicated you might run into, because we're using some extra little connectors here for this very specialty item. All $5 of it off of Amazon. Good old Amazon with their random stuff. But we want to make sure we can show, like, hey, you could if you wanted to do this. If you really want to go that extra distance. Some kid says, hey, Mr. So-and-so in the science classroom, Miss So-and-so in the 6th grade classroom, how do we do this? Well, here's an example of us doing it if you want to replicate that, or they want to replicate that, or want to do something similar yet different. Now, there's another cool project that I wish I could show on camera here, but it's really difficult to show just because of what it is, but it's one of our favorite projects. It is a automatic bubble blower, because we love doing weird cause and effects, and this is press a button, literally make a automatic bubble blower, and it's one of the most whimsical, silly things we have. It's a great project. Pete, would you show that video?
Of course.
Pete's gonna show. Bubble blower. Now the bubble blower is a good example of, it's a servo, it's a single push button, and it's using our little relay here to control just a little tiny motor we had with a fan on the end of it, just randomly in the shop. A really good example, not tough to put together because really just plugging a couple things in and then going through the code and saying, hey, this is how XYZ happens when this happens, do this. And the servo even has 2 points. It goes down, stops in the little pool of bubble water, then comes up again, fan turns on, then it goes back to its home position. Not really complicated, but something that a student could look at and say, hey, what if I want to do something different with this? What if I want to have a different effect to happen? Instead of having the fan turn, what can I do else with that? So we try to really make things nice and open-ended, very student-led, very high interest, because high interest really gets the kids motivated these days. Especially when they've been sitting at home for an entire school year, not doing fun hands-on activities. But we have all these and more projects. We're constantly posting guides on how to use this. And everything we're doing is just standard microbit stuff, but in a nice format that's very easy to expand on components, easy to hook things up, and easy to expand things with the little bit of extra expansion we have on there. like little DC motor parts and servos, sensors, inputs, outputs, like this little display. And the microbit is a fun little platform. Actually, this is a version 2 microbit. Version I can tell because it has little notches on the bottom. Version 2 is kind of cool. It does have a built-in microphone on it, so you can do cause and effect with a loud clap. I think Pete has one of those projects that you clap and something like happens, like it listens for a sound and there's a reaction.
We made the clapper. We made our own.
Oh, that's right, the clapper on like basically like the clapper. You clap on, clap off. We did that with a microbit because why not? It's probably dating ourselves for that because I'm pretty sure was it late 80s, early 90s?
Yeah.
Clap on, clap off. Oh, we're gonna get sued for that logo use or jingle use. It's got the built-in piezo speaker on it, built-in Bluetooth. You want to get really fancy, have one microbit control the other. But also built into here is a temperature sensor, which is kind of nice, and a built-in accelerometer. So you can turn it left and right, move a platform, which is another project Pete wrote up. It's a digital level, but using a microbit. Very simple, very straightforward, very easy. And the kids can then just use those built-in sensors, built-in little drag and drop aspects to make some cool projects. And again, yeah, the microbits themselves are in that $16 to $20 range, and our kits range anywhere from $25 up to much more for the big classroom sets, depending on which one you're going for. But we always have lots of curriculum and resources and example projects galore to go with them, so that you're not left out in the blue. Like, how do I do these crazy things?
Hey Josh, look, this is the code for the bubble blower. It's not super complex.
Oh no!
You
Actually,
know,
a big chunk of that is actually the X and the O is what's
Yeah.
actually happening on the display.
which are just for fun.
Yeah, that's so that there's like a visual, like an X down the middle and an O. But yeah, there's not a whole lot to that bubble blower. It's really simple.
Yeah.
And keeping things nice and simple. And again, if you want to say have the kids just do quote unquote real programming, as I've had people tell me, with Java and Python, you can toggle back and forth in the Microsoft make code visual interface to do one or the other and just have it switch back and forth. You can see how those blocks, what they are in JavaScript, or what they are in that visual drag and drop interface. So it's kind of nice to be able to toggle back and forth. Because quite frankly, if they're learning how logic works, how things interact with each other, and why, that's the big takeaway, especially for younger students, before having to basically learn a new language when you talk about Python or Java or C. It's a new language. It's a lot to learn. I mean, they're probably learning Spanish, French, or German, or God forbid, Latin. Latin. In middle school and high school. But keep the extra languages to a minimum, have them learn and try and have a good time and take away something new. Yeah. So that's this. If you have questions, please email the fine folks at STEMfinity.com. Ta-da! Oh yeah. But yeah, this is available now from STEMfinity. Brand new from us. We just started shipping these in January. We're very happy with the feedback we've gotten from all of our customers who've gotten them and the fun, weird creations they're making with them. Because you can do a lot of weird stuff when you attach Lego to electronics, that's for sure.
I have another video, Josh.
Oh, Pete has another video? Okay, before I go off, another video.
All right.
That was our xylophone. I forgot about that one. And we literally 2 servos and a $6 xylophone off Amazon. And but a bunch of push buttons there. And our big thing was you could use the push buttons to do each note. Each button was its own spot on the X axis.
Hit a different bar.
Yeah, it hit a different bar. I wouldn't call them notes. They're vague. They're vague notes. And also, then the hard part with that from the lesson, the teaching aspect of it, is that everyone can put together the same electronics, but you'd have to then figure out the spot for your xylophone. Where is that C note? Where is that D note? It could be a little different for everybody based on the way their servo is put together, the way their xylophone is positioned on the table. But you can then do that, and then in your code, just this is this note, this is that note, and then afterwards you could then say, hey, play a song. You can just code in your own song. We coded in the melody to Funky Town, which is my go-to melody for silly projects because it's silly. It's Funky Town. But you could do anything you want within that little tone base. Now, Pete, I know, has been slowly chipping away at a nice, gigantic, high-quality glockenspiel, which is the official term for a nice xylophone for musical use. That was a little bit more than $6 off Amazon. but using 4 servos instead to play music with. So we can actually do some nice high quality songs on it, just to show you can go even further if you wanted to, make something musically in tune. I know there's a lot of great videos on YouTube of like people using like floppy disk drives and other weird things to play music and doing some classic tunes on that. But we're like, hey, we can do that with a glockenspiel controlled by a microbit. Why not? Because it's silly and it's funny and it's a good example. Oh, this is
the code for that one.
Oh yeah.
There's a bit there.
Well, a lot of that is, of course, the code for playing that song too.
Yeah,
right.
Over there, Funky Town is on the right.
On the far.
Again, a lot of figuring out
angles.
Yeah, just figuring because we have 2 servos. You got your X and then your how you drop things. But for like a high school kid, that's not that tough to do, especially when there's a really solid example like this of how to put that code together. But there's not a ton there. And again, we're talking about some pretty quote unquote high end things for microbit. When a lot of things we do are awesome meters. How awesome are you? So, I think we're actually over time. We're supposed to go till 30 after. It's 35 after. Well, let's once again say thank you to STEMfinity.com for letting us hang out and showing off these cool things. Oh, yes. Oh, my gosh. If you like STEMfinity, follow them on these wonderful, wonderful, wonderful social media links, to which you're probably on Facebook or Twitter right now, actually. So that's how you found it. This is the bitboard kit from us, the bitboard for the microbit, a great breakout board and full-on kit for doing electronics on a brick-based environment. Yay. And especially doing some fun stuff with microbit. All these projects and more can be found well documented with our bitboard resources on our website. And you can find all these kits and far, far more fun STEM things at STEMfinity.com. So anybody forget anything, Pete? I think I got everything. Good, yay.
Oh, wait, there's a comment.
Oh, there's a comment?
Oh, no, it's just letting them know where they can find it.
Oh, good. Okay, well, thanks, STEMfinity. Thank you for that.
I think we're good.
But in that fun thing, thanks for watching, everybody. I've been Josh, and that's been Pete.
Yeah.
And it's been a cold day here in Wisconsin, so especially for a Monday. But thanks. I hope you learned something. And again, any questions, let us know or ask the fun people at STEMfinity. Always happy to chat about the cool things that are out there for microbit and other fun educational resources. So, yay. Well, thank you. And on that note, we're going to end things.